Hello class, welcome back to lesson 12.3 on properties of a parallelogram. Very sorry that I needed to start this new video. The hovercam has decided it wants to be temperamental again. It's very lovely. Alright, so you guys, here we are with trapezoid frog. So what we have here is that angle O is 42 and angle F is 112. So the property here is this. If two lines are parallel, then with the trapezoid, these same side interior angles will be 180. So it's really straightforward. 180, subtract out the 112, leaves us 68 degrees for angle G. Now if you notice, it's not a parallelogram. The opposite angles are not equal. And the property of common sense should work as well. This is an obtuse angle, that's an acute angle. They're never going to be congruent to each other. So what you have is your own separate 180 on this side. So 180 subtract out our 42 just leaves us 138 degrees. So just like that, we have angle G and we have angle R. All right, now number 2 has some variables in play, but it's not really changing here. We have equations to set up. So normally we're looking to set things equal to each other, add them up to 90, or add things up to 180. So the whole point is, again, if two lines are parallel and AM is parallel to LB, then these same side interior angles add up to 180. So that's the format of both of your equations. Your x's, 3x plus 2x plus 40, that's going to add up to 180. And your y values, 2y plus 38, together those also add up to 180. Now, you guys, something that was very, very detrimental to some of you on the last self-check assessment is that you never finished some of the problems there. Now, here, x is equal to 28, and y is equal to 71. Now here's the thing. On this problem, it literally only says find x and y. But if somebody asks you to find the measure of angle A, you have to go back and substitute. And you'd have 3 times x. 3 times 28 would get you that angle. Or if they wanted the measure of angle B, it's 2 times 71 over there. So please keep in mind that you have to finish the problems if they ask you to. All right, so you guys, those are the main properties of a basic trapezoid. However, we don't just stop there. We can move on to an isosceles trapezoid. Now, an isosceles trapezoid has almost all of the same properties of an isosceles triangle. We're going to have things like base angles are congruent here. So let's go through our vocabulary and make sure we understand what's happening. All right, so properties of a normal trapezoid, meaning one pair of sides is parallel and one pair of sides is not. Now, here's the thing. If you have an isosceles trapezoid, the non-parallel sides are equal, and that makes it isosceles. But then, if two sides are equal, then the angles are equal as well. So these base angles of an isosceles trapezoid would be equal. But here's the problem. You can't just stop there. There's actually not one pair of base angles. If I flipped this trapezoid over, these are still the parallel bases. And if you have two equal sides, aren't the base angles congruent? So what you have here is both pairs of base angles are equal to each other. Okay? So that's our basic property there. What you have here are base angles, and you have base angles there. Base angles congruent. All right, so if you want to apply that property here, if I tell you that ABCD is an isosceles trapezoid, if you have two equal sides, then you have two equal angles. All right, so this pair of angles and that pair of angles will be equal. All right, leaving 135 degrees for both angle A and angle B. All right, if you wanted to be crazy about that, you could say opposite angles here are actually supplementary. All right, how are we doing so far? That's not so bad, right? All right, you guys, one of the things here, and it's not going to be a huge thing that we're going to study just because of the sake of time, but I want you to consider where we've seen congruent diagonals before. When you had a normal parallelogram, false, the diagonals were not congruent. Long diagonal, short diagonal. But when we moved on to rectangle, because it didn't tilt over and extend to either side, you had equal lengths to travel, thus those diagonals were congruent to each other. If you have like any normal trapezoid with non-equal legs, do you see how that's a very short diagonal, but that would be very, very long right there? But when you have an isosceles trapezoid, the distance between that diagonal and that diagonal is congruent because B and C are pretty much equitably distributed there. So if you have an isosceles trapezoid, I just want you to be aware that you definitely have congruent diagonals. Now, this is why I really miss seeing you guys in person because this is really exciting to me. You actually have 4 triangles here. Would it surprise you to see that you actually have one pair of congruent triangles formed and one pair of similar triangles formed? So here's the thing. If you guys have an isosceles trapezoid, that pair of sides is definitely congruent. What also happens here, the diagonals don't bisect each other, but what they do is they cut each other into congruent pieces, meaning those top pieces are congruent and those bottom pieces are congruent. Now, you guys, what you have here is all 3 sides of one equal to all 3 sides of another. Triangle 2 is actually congruent to triangle 4. Now, you don't have that over here, and you don't have congruent sides either. See how triangle 1 has 2 tick marks and triangle 3 has 3 tick marks? But what you have here is the corresponding sides are in proportion and the included angles are equal. So what you actually have there is side, side, side congruence for the first pair and side angle side similarity for the second pair. Triangle 1 would actually be similar to triangle 3. I think that was exciting to talk about. I'm not going to ask you any questions about that, but I don't want to lose the things that we've already learned in this class. All right, let's answer some questions on an isosceles trapezoid. So I'm going to pause the video. Hopefully it will allow me to come back after I hit play. Why don't you give it a shot and find me the measure of angle BAD. Good luck. All right, class, welcome back. So if you have been successful finding the measure of angle BAD, you would have gotten 70. All right, let's see how we did with this. So you guys, what you have here is an isosceles trapezoid. You have 2 equal sides. Now, we want to figure out what the relationship between those angles are. Please, I beg you, do not set them equal. This is acute and that's obtuse. They are not equal to each other. But if you have a hard time seeing the relationship here, please understand, aren't the base angles congruent in an isosceles trapezoid? So I can move that over there if I want to. And now do you see a little bit more clearly the relationship of 180 degrees? So 2x and the 3x plus 5 have to add up to 180. Now this is what I was referencing on one of the earlier problems here. It is not enough to just solve for x. All right, if you pick the choice or just leave the answer as x equals 35, you're not going to get credit for that. We're looking for angle BAD. BAD is that angle there. So angle BAD is equal to 2 times x, which gets us 70 degrees. All right, that wasn't so bad right there. All right, now this one looks a little obnoxious here, but what I'd like you to do is use your knowledge of an isosceles trapezoid and basic principles of solving equations and find me the perimeter of DEFG. All right, good luck. I have faith in you. Okay, welcome back, class. We are trying to find the perimeter of trapezoid DEFG. So I just made a note here that the legs of an isosceles trapezoid have to be congruent. So if DE is parallel to GF, which makes those the parallel sides, these are the congruent legs. Now, you guys, just like with any solving, the whole thing is making an equation. Guys, 180 and 90 degrees are not on the table here. You're not dealing with any angle measures. So you have to find another relationship, and the relationship has to be equal. This leg is equal to that leg. So in order to find the perimeter, you have to know what the value of x is. That requires an equation. All right, so that wasn't so bad. Just understanding that if the two sides are equal, you can set them equal to each other and solve. So x is equal to 3. Now, guys, the only other thing to recognize is that every side here is in terms of x, so all we have to do is substitute and solve. All right, so 4 times 3 minus 2 gets us 10 for that side. 3 times 3 plus 2 gets us 11 for that side. All right, 15 minus 3 gets us 12 for that side. And this should be a double check here. These are supposed to be equal, so if we don't get 11 here, we did something wrong. 2 times 3 plus 5 is definitely 11. So you have all of the sides there. Your perimeter is just 10 plus 11 plus 12 plus 11. So the perimeter is 44. All right, very, very, very well done. Now, we're going to move on to our last type of trapezoid, which is called a right trapezoid. Now, guys, the whole thing here with the right trapezoid, we're not going to spend a ton of time on an actual right trapezoid. What we want to do is really figure out what a right trapezoid is and how we can apply that to an isosceles trapezoid. Because anytime you have a right triangle or a right trapezoid or a right anything, it's all about 90-degree angle, which means it's an altitude. So side AB here is perpendicular to BC, so that makes that perpendicular. It makes it an altitude. It makes this a right trapezoid. Now, just because we can't really get away from it, if you have any altitude in the trapezoid, we're generally going to be looking to use our Pythagorean theorem. Because if you can turn something into a right triangle, you'll always have those applications. Now, here's the thing. When you're looking at this problem, I haven't really told you what I'm looking for yet, but I might be looking to find the perimeter of this trapezoid. So what I need to do is find DC if I want that perimeter. But how on earth do you do this if it's a trapezoid? So you guys, it's all about dropping altitudes inside a trapezoid. Do you see right there? If I drop that altitude, what you've now created here is a rectangle. Think about this. If this is a trapezoid, the opposite sides are parallel. So therefore, if this is 90, that's 90. Those would then also be 90, which makes it that rectangle. So this is important here. Opposite sides of a rectangle are congruent. Good. Now, we have to work for the length of this side of that triangle here. Because I know the entire side of BC is 20. If I wanted to find DC, I would have to have that other side of a triangle. So it's just about 2 parts adding up to a whole. Would you guys agree from there to there is 10? So from here to here is also 10. Now, This is the whole deal. If you've got 20 for the full length and 10 for the first part of it, it just leaves us 10 for the second part. All right, I'm not really interested in finding DC right there. I'm really more interested in manipulating these problems. All right, so take a look over here at the second one. Let's say the question said, find the altitude. So right now, I know that AB and CD are not altitudes because they're not perpendicular to the base. So it has to be on your own will. You have to be willing to drop an altitude in a trapezoid. So that's a terrible looking altitude. I apologize for that. But the thing is here, if you really want to be successful with this, generally what you need to do is take the shorter side of your bases and drop both altitudes. Do you guys see how you have a rectangle there right in the middle? That's going to help you apply that concept of opposite sides being equal. All right, so here's the thing. I need the length of one of these altitudes. Now, if this is an isosceles trapezoid, if that's 25, the other side is 25 as well. So it doesn't matter which altitude you focus on. So here's the thing. If you want to find that orange length and you have that hypotenuse length, I need this length right here. Now guys, it's not magic. Don't just go 26 minus 12 gives you that, because that's not true. Aren't there 3 separate pieces that add up to 26? Now, these problems usually only work when we're dealing with isosceles trapezoids, because that right triangle over here would be congruent to that right triangle over here. So look how this works. If BC is 12, this middle section is 12. So 26 minus 12 leaves us 14. Now the whole point is those two pieces are congruent. Cut that right in half, you've got 7 and 7. So now, if you were looking to find the altitude right there, like squared plus like squared equals the hypotenuse squared, and you could use your Pythagorean theorem to solve. All right, I know there's a lot of steps there, so let's see if we can digest that. I'm going to pause the video, and I want you guys to get set up with that. If you feel like you're confident finding the altitude of this isosceles trapezoid, have at it. Good luck. Okay, welcome back, class. I left you trying to find the altitude of this isosceles trapezoid ABCD. Now, if you have found that successfully, you got 15 as your altitude. If you have no idea where to get started, that's what I'm here for. So let's go. All right, I've just taken the liberty of labeling the bases of 20 and 36 because AB is parallel to CD, which is a total lie. I'll go fix that. BC is parallel to AD. I really need to stop telling lies. I apologize. All right, so here we go, guys. AB is 17, and if this is an isosceles trapezoid, the other leg is 17. So if I want an altitude, I just go to one vertex, and I drop the perpendicular to the opposite side. However, if you want to use that 20, you need to box that out and drop both altitudes. So the whole point is I wanted to find that length right there. And you know as well as I do, if you want to use the Pythagorean theorem, you have to have that other side of that right triangle. So this is the fun part. It's like a puzzle, right? Opposite sides are equal, so that's 20. So whatever is left over is going to be split equally between those pieces. So we're going to take that 16 and split it right into 2, and each of these lengths are 8. Now you have the option. If you understand that you have an 8, 15, 17 Pythagorean triple, you can go immediately and say the altitude equals 15. But if you've decided not to learn those, you're just missing a leg of that right triangle. Leg squared plus leg squared equals your hypotenuse squared. And this is nothing that we haven't done now 100 times. Okay, so x is just going to be equal to 15. And that's it. All right, you guys, we've now reached our final question on isosceles trapezoids. What I'm going to leave you to do is draw your own trapezoid. See how it goes. What I want you to do is find the perimeter of this trapezoid. Good luck. Okay, welcome back, class. So if you have been successful in finding the perimeter of the trapezoid they have described, you would have gotten a perimeter of 104. Job well done. All right, so you guys, let's see what we've got here. The lengths of the bases of an isosceles trapezoid are 20 and 44. So obviously shorter base and longer base. And they tell us the altitude is 16. What we want to do is find the perimeter of the trapezoid. All right, because this is an isosceles trapezoid, those two sides are equal. And I need to find one of those equal legs. So the whole point is, here is your right triangle again. It's all based on the concept of an altitude. So I need that bottom piece. Guys, even though they didn't tell you to draw in the second altitude, I hope you realize now you have to. That's really a requirement of this. So let's see what we've got here. If that's 20, this guy's 20. So same deal, 44, subtract out what you have, leaves you 24 to split equally between those two pieces. All right, so you've got 12 and you've got 12 right there. So we now have enough information to solve for that hypotenuse. All right, so here we go. This is very exciting stuff right here. Leg squared, hypotenuse squared. All right, so x squared is equal to 400, so the length of our hypotenuse is simply 20. And if this is an isosceles trapezoid, that is also 20. So, perimeter, we're ready now. 20 plus 20 plus 20 plus the entire length of 44 gives us a perimeter of 104. All right, so that wraps up our properties of a trapezoid. I hope you've enjoyed that. And as always, thank you very much for listening.